Chapter 11 is about gases. And the author opens with this idea about extra long straws. And I'll try to make this go quickly. So, kids think, well, I could make a really, really long straw, right? And suck soda up. And it's like, well, as a young adult, you think, well, hey, we could take this farther. Let's make a straw and drink soda. We'll put the bottle of soda down on the patio down there in the courtyard, and then we'll be on the roof of the building and we'll drink soda through the straw, and that'd be cool, right? You can't do it. It's not possible. And understanding of gases will explain why that's not possible. Have you ever thought about how does a straw work anyway? How is it that we're able to suck a liquid up through a straw? It's actually being pushed up through the straw by the atmosphere. So there is air, right? And air bounces around and it puts pressure on this liquid. And when we reduce the pressure above the liquid, the atmospheric pressure is able to push the liquid against gravity up the straw. If the straw was perfect, not like you're taking straws at the restaurant and sticking them together, but it was actually one continuous piece, no leaks, had rigid walls, so it's not going to collapse in on itself, and you drew a perfect vacuum. You sucked all the air out of there. You could only suck water up about 10.3 meters or 34 feet. Beyond that, it just will not go. And this has applications for pumps. Out in the country, people have wells, and you have a pump, and you're trying to pump water up out of the ground. You don't have the pump on the surface and suck the water up. You put the pump down in the ground, and you push the water up. Because otherwise, unless your water table is above 34 feet, which is just not happening at all anymore, there's no way that a pump can suck water up. And so we're going to learn about that and why that is. So pressure. Pressure is force exerted per unit area. And as gas molecules move around, they bump into things. They exert a force over an area. The force is small, the area is small. The pressure of many, many molecules bumping into you is significant. On Earth, the gas molecules in the atmosphere exert an average pressure of 101,325 newtons per square meter. That seems like a really big pressure, a really big number. Well, it's just because of the units. Or 14.7 pounds per square inch. That's abbreviated PSI. So on your tires on your car, and you need to go up to 35 PSI or whatever. Pounds per square inch. Pound is a unit of force. Square inch is a unit of area. It's a force over a given area. 14.7. In a straw, here's the straw open to the atmosphere. We know that the soda is just going to be at the same level inside the straw and outside, because there's pressure from the atmosphere pushing down both on the outside of the straw and on the inside of the straw, and the soda stays in the bottom because of gravity. If you suck on the straw and you lower the pressure here, the pressure outside is still the same, the pressure inside is lower, the outside pressure is going to push the soda up into the straw. We get a difference in pressure between the inside and the outside that's equal to the height difference inside and outside. So if you had a perfect pump and a perfect tube here and pulled a vacuum, the soda, anything that was aqueous, would only go up about 10.3 meters. And that's because that's what the atmospheric pressure can support. Atmospheric pressure pushing down, pushing the liquid up, but the opposing force is gravity pulling down. And so you can't suck water up higher than 10.3 meters.